Trina Solar's product manager, Rocky Lee, is joining us today to present the company's Vertex N-iTOPCon module series and also its technology development roadmap. Welcome to TaiyangNews, Rocky. The floor is yours.
Hi, Anu. Thanks for having me. I'm going to share my screen. Okay, hello everyone. This is Rocky from Trina Solar, and today I will bring you the Trina's latest high-efficiency N-type i-TOPCon cell solar module and its technology roadmap introduction. We are leading the N era of the solar energy. My today's presentation will cover two major parts. So the first part is the Trina Solar i-TOPCon technology roadmap introduction. And the second part is the i-TOPCon high efficiency module series introduction. Let's come straight to the point. So for this page, we are showing the Trina's i-TOPCon technology development roadmap. Basically, we're containing four major stages. So the first stage is from 2015 to 2019. We call it i-TOPCon. And I represent the industrialization. And the second stage is from 2020 to 2022 is the i-TOPCon Plus. And in this stage, we just integrate the TOPCon technology with our 210 technology platform. And the third stage is right now is from 2023 to next year. We call it i-TOPCon Advanced. And then to look into the future is our i-TOPCon Ultra and Tandem technology stage. So let's look into the details one by one. So actually, Trina is one of the earliest who's put into the research and development into TOPCon technologies. In 2015, we're established our first TOPCon solar cell lab based on our state key laboratory of the photovoltaic science and technology. And after several years of the R&Ds, we built up our first production line, 500 megawatts scale, a pretty big volume at that time. And it's on 158.75 millimeters wafer size based. And based on the innovative hydrogen passivation technologies, the cell efficiency is 0.2% better than the industrial average at that time. So the mass production efficiency is around 23.5%. And also we set a record 24.58% in 2019. And then we move into the second stage. Trina introduced the 210 technology platform back in 2020. And we just embed this 210 technology platform with the TOPCon technologies. And the average mass production cell efficiency during the second stage is around 24.5%. And we also set several records of 25.25, 25.42, 25.5% world record at that time. And we also have the 500 megawatts supply scale. And during the first two stages, we built up several technology leading projects, which contains the utility ground mount, big scale 100 megawatts of the solar projects, which also contain the residential projects in Europe. And now we're on the i-TOPCon Advanced stage. And this time we upgrade our i-TOPCon solar cell with the several major technology innovation, which including selective emitter, backside microstructure reflector, high doping and low composite TOPCon structures. And now our cell efficiency can go up to 26.2%. And based on the 210 platform, we also introduced the rectangular cell, 210R solar cell, and also introduced three golden sides of the module format. And also during this stage, we scaled up our capacity. Now our i-TOPCon solar cell capacity is up to 40 gigawatts plus. And also we comprehensive our product portfolio as well. And to look into the futures, we're foreseeing the full frontal passive vision contact technology, which efficiency expected to exceed 27%, and the i-TOPCon plus perovskite tandem cell technology can lead the solar cell efficiency go up to 30%. So today, just like what I mentioned, we will focus primarily on the i-TOPCon Advanced. So to introduce the i-TOPCon Advanced, so the four major innovations. The first one is the innovative rectangle cell. So based on the 210 platform, now we are introducing the G12R, also known as 210R, 210 millimeter times 182 millimeter wafer size cell. And with these cells, we can design the golden sized modules, which I will elaborate a little bit later. And the second one is the large area boron doped by laser selective emitter technologies. The cell efficiency will increase 0.2 to 0.3% by these technologies. And the third one is the backside microstructure reflectors. It can increase the inner back reflectivity by 25%, which can further enhance the cell efficiency. And the last one is the high doping and the low composite TOPCon structures. We are adopting the PECVD route, which doping density is very high. It's 2 to 3 times higher than that of the conventional LPCVD technical route. And with this new i-TOPCon Advanced technology route, our cell efficiency improvement curve is shown in the upper left corner of the chart. And with different format module design. So for the utility scale modules, the module power can exceed 700 watts, and we are expecting 710 watts, 712 watts in the next several years. And for the residential modules on the right bottom, you can see that our modules power output exceed 450 watts. And for the commercial and industrial on the left bottom side, you can see our medium format module design. The module power exceeds 600 watts as well. And then let's go into the second part. Now, based on the i-TOPCon Advanced technologies, Trina's, we just introduced these 3 modules, and these 3 modules is also launched during the past SNEC Expo and Munich Intersolar Expo. So these 3 modules cover from small module to medium size and to large size with different format design. It covers all the application scenarios from the residential rooftop, commercial and industrial, and the utility ground mount power plant. And comparing to the industrial average, our modules have 20 watts to 80 watts more powers per panel. And just like what I mentioned, these modules just adopting the 210 and 210R wafer platform, and with the innovative format design, we designed these 3 golden sized module format. I will introduce more one by one. So why it is the golden size. So first, let's look at the small modules. This is the residential modules. We call it Vertex S Plus. So it's the upgrade version from the previous Vertex S. So when we introduce the Vertex S modules, it is highly welcomed and by the Europe market, Australian market, or Japan market. And these modules is small in size, big on power. Now, based on that, with the i-TOPCon Advanced technologies, the module power can further enhance by 30 watts, and the efficiency can go up to 22.5%. And comparing to the industrial average, 182 modules, we can also have 25 watts more power per panel. So under the same roofs, with these new modules, we can have 5.88% more installation capacity under the same roof. Additionally, one significant point is the module areas. This module areas is very close to the 2 meter square meter is the limit of the small sized modules. So this is the Germany building regulations. And with this module design, it can not only make the modules have more power, but in terms of the container space utilizations and the shipping cost, it can increase the shipping capacity and reduce the shipping cost by around 6%. And I'd like to elaborate a little bit more on this page by why we're saying that this module is the golden size, why it is the ultimate small size format design. So when we're designing these modules, we're considering several factors, because if you're facing the residential rooftop scenarios, actually we're facing the complex situations, the different inclination, different tilt angles, and also when we are communicating with the dealers, distributors, installers during the Intersolars, they're all talking that the safe and handling convenient is always at the high priority. So when we are designing these modules, we are exploring the limit on the small sized modules. So we find 2 boundary conditions. One is the size, less than 2 meters square meter, and the other is the weight, less than 51 pounds. And design these modules. And these modules with this limit, this module is small in size and big on power. It can provide the extremely safe and installer, distributor friendly, easy to handle and install from the physical characteristics perspective. And on the other hand, this time we also upgrade our modules encapsulations from the traditional backsheet encapsulation to the 1.6 plus 1.6 light door glass encapsulations. From these perspectives, it can provide safer solutions for the client as well, because it can provide better anti-fire performance, and it also has better resistance to deal with the aging factors in nature. And the next is the medium format modules. And this module is designed for the utility and commercial and industrial rooftop. And these modules, if you compare the characteristics with the reference modules, we can notice that is a little bit longer on the length side than the industrial standard 182 modules. And the other point is these modules voltage is a little bit lower than the reference modules, so which can ensure that we can connect 2 additional modules per strings in the solar system. So when you place these modules, place the strings on the trackers, for 1P tracker systems, you can place more modules, and it can utilize the single tracker row length more better than the reference modules. So as you can see the comparison here, we can install 13% more powers per single tracker row. And what is the benefit from the more power on single tracker row? So for the tracker cost perspective, it mainly contains 2 parts. One is the structural part and the motor communication part. So the higher power on one single row, it can reduce the overall amount of the steel used. So this portion will contribute around 0.3 US cent per watt. And the other thing is because you have higher single tracker row power, then you have less tracker units. Then the motor communication part would be less. So this portion would be amortized the cost. And this portion will contribute additional 0.2 US cents per watt. So the total saving around 0.5% from the tracker perspective aspect. And so after the tracker compatibility and the perfect match with the trackers, the other concept is why this module is another golden size is the utilization of the container space. And comparing to the reference module, as you can see here, we can increase 4% of the container space utilizations, and also the length, width, and height of the container we still have slide space to be loaded and unload the modules. So basically, 98.5% is maximize the utilization rate of the container. And compared to the reference modules per containers, total power, we have 5.2% more of the power, which equals 5% less of the freight cost. And then the third one is our large format modules. And this time the i-TOPCon advanced with the solar cells solar cells upgrade. Now the module power is upgraded from the previous 680 watts to 700 watts right now. And the other thing is this module is adopting the vertical package, and this package is fully utilize the container space as well, as you can see from here, 97.6%. And comparing to the industrial larger format 192 modules, in terms of the shipping cost, it has significant advantage. And to make a summary, why we call these three module format are the golden sized, because the residential modules is we found the limit of the small format module design, and also small in size become power is highly recognized by the installer and dealer. And for the medium sized modules, commercial rooftop modules, so just the modules can increase 4% and can maximize the container utilizations. And the utility modules, also these modules is this size is also standardized from the industry. And we also noticed the trend from the SNEC and Intersolar that this golden size design philosophies is widely acknowledged by the partners and players among the industry. And some incomplete statistics. So now more than 3 players upgrade the small sized modules to this 2 square meters limit small sized modules. And in terms of the medium sized modules, and over 7 players upgrade the module size from the previous module size to the new golden size. And in terms of the big sized modules, actually back to 2020 is when Trina introduced these modules. This module size is standardized, and now after 2 years development, there are a lot of players and there are a lot of partners already join this module size, and the entire supply chain also is matured enough to have this module size. And then let's look into the some case study, hypothetical BOS and LCOE assessment in terms of our medium-sized, golden-sized modules and large-sized format modules. So let's first look at the medium-sized modules, comparing with the reference modules. You can see that because we have a little bit longer on the length side, so our module have more areas to absorb the light and have higher power. And aside from the single panels, higher powers, the other significant point is we have lower voltage. So which means in the system side, we can connect more modules per string. So when we have a hypothetical study of the BOS and LCOE, we can see that on the string side, we can connect more modules, 30 comparing to 28, and with higher single panel powers in the total stream power, we have 13% more. And when we connect this module, we place these modules into the single one portrait tracker system. So we are doing these calculations that we can have significant savings from the tracker part, just like what I've introduced from the structural part. We can reduce the consumption of the steel, and from the motor and communication part, we can reduce we can amortize the motor and communication controller cost. And the overall speaking is around 0.6% US cents per watt saving from the tracker perspective. And the other thing, because of the higher voltage on the electrical part, we have we can reduce the total string numbers. So and so when you connect each strings with each others, the corresponding connectors, PV cables, low voltage cables, and cable trenching will have savings as well. And then in the overall calculation, we can see that compared to the reference modules, we have 0.85% US cents per watt, and the savings mainly come from the module installation, electrical system, 1P tracker system, and the transportation. And then when we put this into the PV syst LCOE analysis, we are seeing a 1.2% LCOE reduction compared to the reference module. Same logic for big modules. We compare our 600 watts modules. So this is 695. This is our current mainstream production power, and comparing to the 182 620 watts modules. The same logic here. We can notice that the voltage is still lower than the reference modules, and if you place in the systems, we are seeing the 31% more stream power than the reference module. And then the savings, basically the same logic. The BOS side, we have 0.5% lower BOS, and the savings come from module installation, electrical system, and the mounting structure. And in terms of the LCOE study, we are seeing the 1.1% lower of the LCOE. And aside from the performance and BOS LCOE advantage, our N-type modules also demonstrate high reliability. During the SNEC, we are honored to be awarded as the PVL top performer 9 years in a row. Our medium format modules perform very well in every test items of the PVL extended reliability test. And also we are doing another test in RETC. Our big sized modules also perform very well in each test items of the RETC extended reliability test. So in terms of the supply, so now by this year's, we have 95 gigawatts module capacity, 75 gigawatts cell capacity, and 50 gigawatts silicon ingot capacity. We are fully vertically integrated, and among these, i-TOPCon supply capacity is 40 gigawatts. And then coming to the end, quick summary. So i-TOPCon advanced with the selective emitter, backside microstructure, reflector, high doping and low composite TOPCon structures, empower the top efficient solar cell and module, and empower the efficient product portfolio. And then we introduced the 3 golden sized module format design, which is also widely acknowledged by the industrial partners. So the 2 square meter limit size, small sized modules, and the container space maximize used medium sized modules, and which is also the perfect match for the tracking system, and also the standardized large format modules. And i-TOPCon Advanced plus the innovative 210R platform, our product demonstrate high values in each application scenarios. And then our modules also, in terms of the reliability side, our module is also endorsed by the reputable third parties, and we are also the top performers 9 years in a row. All right, that's all for my presentation. Thanks for listening.
Thank you, Rocky. That was a very in-depth presentation. So I just wanted to ask you one question. So Trina is offering products based on G12 and 210R. So which one would you say is better? And which one is your main product?
This either 210 or 210R are all our mainstream product. It's basically the customer oriented, right? So this as you can see, these products are positioned for the different application scenarios. So these are all our mainstream. It's totally based on our customers' demand.
Okay, all right. Okay, thank you, Rocky. Thank you so much. And if you could please stay back and join the chat. There are some questions I think you might have to answer there. So it would be really nice.
Absolutely. Absolutely. Thank you. Thank you.
Yes.
Bye-bye.
Bye.